everyone, welcome to a little pre-lab video just to get you guys kind of started on your KSP solubility product constant guided inquiry experiment. So in this particular experiment, what the objective is you want to try to determine the solubility product constant for an ionic compound. And in this case, you guys are going to be mixing calcium nitrate with sodium hydroxide. And when you mix those two solutions together, the precipitate is going to be calcium hydroxide. So the whole objective is to try to figure out what the correct KSP value is for calcium hydroxide. And in the procedure, they have you guys doing something called a serial dilution. And I thought it might be helpful just to try to explain what a serial dilution is before you step into the lab next class. So it's a pretty easy concept. You're just continually doing a dilution over and over and over again. But I just want to confirm the math with you. All right, so in the very first well plate, they want you to stick some stock solution of 0.10 molar calcium nitrate. And then in the second well plate, and actually second, and then you can keep going third and fourth and fifth, all the way out to, gosh, I think they have you doing 12 well plates. You're going to add 5 drops of water. So each of them are going to have 5 drops of water. But in well plate number 2, what you're also going to add is you're going to be adding 5 drops of the 0.10 molar calcium hydroxide, okay, into well plate 2. The total volume here, would technically be 10 drops, right? So you're probably curious about what the dilution or what the concentration would be in that particular well. So your original formula for a dilution is M1V1 is equal to M2V2. And we can use that in this particular dilution pretty easily. The initial concentration of your solution is 0.10 molar. And you used 5 drops of that. And I know that drops doesn't seem like a very accurate volume, but that volume is going to be able to be considered the same on both sides. One of the things that you can do in the dilution formula is if you use, like, say, liters on one side, if you use liters on the other side, then you're good. You can use milliliters on one side and milliliters on the other side, and you're fine. So in this particular case, we're going to be using drops. It's okay to do that because it's still going to give you an accurate determination of the second molarity. So we don't know what M2 is, but we do note that the final volume of that diluted solution is technically going to be 10 drops. All right, so at this point we can solve for the molarity of the calcium nitrate in well 2. So I got a concentration of 0.05 molar. All right, so that solution, once you prepare it, you're going to want to mix it with like a toothpick to make sure that it's thoroughly mixed. And then what you're going to do is you already have 5 drops of water in well plate number 3. And what you're going to do is after you've prepared this solution in well plate 2, this 0.05 molar, what you're going to do is you're going to remove from here, you got 10 drops in here, you are going to remove 5 of those drops and place them into the next well. So technically what you've done is you've already got the 5 milliliters of water in here, and what you added was 5 milliliters now of the 0.05 molar solution. So what you can do now is determine the concentration all over again. Remember, the total volume is still 10 drops, and if you look at this formula, all I'm going to do is change this initial molarity. So now the initial molarity is going to be 0.05 molar. Okay, you see how I just changed that? Grab a calculator and solve again. Now the concentration will have dropped to 0.025. You see how it's always halving the concentration as you go through? So you're going to do the same thing again in well plate number 3. Mix it really well with a toothpick. Remember, the final volume is going to be 10 milliliters in there. And basically what you're going to do, you already have 5 milliliters of water again in this next well, and you're going to extract 5 drops from well plate 3 and take those 5 drops and drop it into well plate number 4. All right, I think you guys understand that basic technique there. And now that you have all of the concentrations laid out, you have to realize that in each case, in each one of these wells, what you did is you extracted 5 milliliters out all right, to make the other dilution. Well plate number 12, this guy right here, technically is going to be the only one that still has 10 drops inside of it. So what they want you to do before you move on is they tell you to withdraw 5 drops from this last well plate and just discard it, just throw it away. You want to know why? Because each of these wells is going to have a remainder of 5 drops. Okay, so each one of these wells now has 5 drops inside. And let's just take, for example, I'm going to take a look at, let's just look at like well plate number 10. In well plate number 10, you have 5 drops of approximately 0.00020 molar calcium nitrate. And what they want you to do now that you have all of your dilutions done is they want you to add to each one of these wells 5 drops of the sodium hydroxide. All right, so remember, you've taken 5 drops out of each one of these well plates. There's 5 drops remaining. So if you think about that, you are going to be adding an additional 5 drops to the 5 drops that are already in there, which gives it now a total of 10 drops into each of these with the sodium hydroxide in it. Okay, you've added 5 drops of sodium hydroxide to each of these well plates. So if you had to figure out your new molarity, all right, you see how the addition of 5 drops of of sodium hydroxide is actually going to dilute that solution one more time. So basically what we did is we diluted it once, and then when we add the 5 drops of sodium hydroxide, you diluted it again. So now we have to determine, with the addition of the 5 drops of sodium hydroxide, what the new concentration would be. So in well plate number 1, we initially started with our stock solution of 0.10 molar. But with the addition of 5 drops of NaOH, this gets cut in half, and it will become 0.05 molar of the calcium nitrate. Oop. CaNO3 2. In well plate number 2, we initially started with 0.05. So the 0.05 molar gets cut in half and becomes 0.025 molar calcium nitrate. So you're going to want to figure out the concentration of each of those as you go through. But here's the bottom line. Eventually, with the addition of the NaOH, you're going to want to mix each of these well plates very thoroughly, so timing is of the essence. You're going to want to mix all of these very thoroughly and then wait at least 4 minutes before you try to determine if there's precipitate inside. You're really going to want to make sure that you look very carefully. So if you want to, you can slip like a dark sheet of paper underneath to try to find the white precipitate. I believe that calcium hydroxide is white. So a dark sheet of paper underneath might help. And you're going to basically find, I don't know, let's pretend that you got precipitate, 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 precipitate maybe, and then everything from here down is clear. There's no precipitate left. So that means that the KSP value must lie somewhere between these 2 well plates. And what you would have to do is to go in and determine the KSP expression, which it's always products over reactants. So if you think about calcium hydroxide, remember calcium is +2, hydroxide is -1, and so you need 1 calcium and 2 hydroxides like this, okay? So what you'd want to do is you'd want to get the concentration of your hydroxide ion, make sure you square it because there's a coefficient of 2, get your calcium ion, concentration of that, and then down on the bottom would be the calcium hydroxide. So there's technically, oops, sorry, bracket there. There's technically what your expression is. So at this point, you would have to plug in some of those values to try to figure out where was the last well plate that you had a precipitate and the last well plate that you did not have a precipitate. Now remember, anytime you're looking at your KSP values here, one of the things that you have to take into consideration is whether or not we actually need to have the solid down on the bottom, right? Remember how we talked about how solids, we can't really get a concentration for that? So we always just kind of remove that bottom piece right there. So technically our KSP value can be determined directly from the hydroxide ion and the calcium ion. Now of course in any good experiment we always want our our results to be reproducible. In other words, you want to try to, be able to see it again. So what they expect you guys to do is, instead of starting with the calcium nitrate like you did here, we put the calcium nitrate and we did a serial dilution. What they want you to do next time is actually to throw the NaOH solution in first, and then do a series of dilutions. And then once you get those dilutions done, you're going to throw the calcium nitrate in. So it's a good way to just kind of confirm your results by doing it backwards. Instead of starting with calcium nitrate, you'll start with sodium hydroxide. So let's take a look at some sample data. So here's just a total example. Let's pretend like the last well that had precipitate was well number 5, and that the first well with no precipitate was well number 6. So all you would have to do is determine the KSP value. And remember, the KSP can be determined by the concentration of your calcium ion multiplied by the concentration of your hydroxide ion, and don't forget to square it. So in this case, your KSP for this one would be approximately 7.8 times 10 to the negative 6. And then you come down here and you get the KSP value in this region. And the KSP value over here, I'm just going to fast forward here, would be 3.9 times 10 to the negative 6. So what we could say is that the KSP for our calcium hydroxide should lie somewhere between about 4.0 times 10 to the negative 6 and approximately 8.0 times 10 to the negative 6. So that's what we could determine based off of this data. Now, in the challenge part, that's part 2 of your guided inquiry lab, what they expect you to do is to be able to zero in on a more precise value. Now, you need to think about what type of procedure you would follow in order to get a better estimate of the value between here. So you would have to zero in on maybe a concentration that might, like a serial dilution, if you will, that would zero in on some areas in between these concentrations that you have here and here. So that takes some critical thinking, and it takes some time to decide on a good procedure that could get some concentrations that maybe are between these. All right, everyone, I hope that helped. You should be able to dive into the pre-lab and be able to do at least your procedure at this point, and get a good data table and be ready to look very closely at some precipitate when you guys come in on Tuesday. Talk to you later.